pandemic has caused a bicycle boom not only in the Philippines but also across the globe. People of all ages from all walks of life turn into cycling for transportation, recreation, exercise, or sport. When I go uphill, why is it that no matter how fast I cycle, my speed is still slowing down? I will tell you why. Let's discuss acceleration of an object on an inclined plane using Newton's second law of motion. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force and inversely proportional to the object's mass. An excellent application of Newton's second law of motion is cycling. In this scenario where I go on a climb, we must first determine the forces acting upon me in order for us to understand why I tend to slow down while going up on an inclined plane. Let's look at the free body diagram. So this is the inclined plane, the x-axis which is parallel to it and the y-axis which is perpendicular to the x-axis. Let's denote this as the positive x-axis and that one as the positive y-axis. To simplify the FBD, we consider the cyclist and the bike as one body and is represented by this law. The body is accelerating in the x direction, so we must determine the sum of the forces along the x direction, and to figure this out, simply draw in all the forces that are acting on the object. The first force that we need to consider is the force of gravity, which is the product of the mass and acceleration due to gravity, which is equal to 9.8 meter per second squared. Fg always acts on the body in the downward direction, but since this is an inclined plane, Fg can be separated into its components. Fgx is parallel to the surface, and Fgy is perpendicular to the surface. Based on geometry and trigonometry, Fgx is equal to mg sine theta, and Fgy is equal to mg cosine theta. The next force is the normal force, which is the force that keeps the object from falling through the inclined plane. Normal force is always perpendicular to the surface. Then, we also have friction force, which opposes the motion of the cyclist, so it is drawn toward the opposite direction. Friction force is equal to mu times the normal force. Another force that we should consider is the applied force exerted on the pedals and by the tires of the bike on the road. Therefore, the net force along x is equal to the sum of acceleration due to gravity toward negative x-axis, friction force also toward negative x-axis, and lastly, applied force. This is why it feels harder to pedal up an incline because there's an additional force that has to be overcome in order to progress. So that's why I'm decelerating because of these opposing forces. If you feel your efforts are not enough, don't worry. Blame it to the opposing forces.